Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our third lesson on a given Form 4 mathematics topic called integration. So we are looking at our second aspect of this particular topic, which is called definite and indefinite integrals. So what do we mean by definite integrals? So definite integrals, these are integrals whose limits of integration are defined. A good example is part B. We can see that we have the limits of integration, that is from 2 up to 4. So this one, we call it the lower limit. So this is what we call the lower limit of integration. Then this one, we call it the upper limit. This is the upper limit of integration. So an integral whose limits of integration are defined, we call it a definite integral. So part B is clearly a definite integral. This is a definite integral. Then another point to notice that for the case of definite integral, the constant of integration, the constant of integration will always disappear. It will always disappear. It will always disappear during the process of integration. It will always disappear during the process of integration. So basically we are saying that whenever you substitute the limits of integration, then the constant of that integration will always disappear. Therefore, there's no need of including it. Then the second type of integral is what we call indefinite integral. From the word, it simply means that here the limits of integration will not be defined. So a good example is part A. You can see that the upper limit, there's no limit. Then for the case of lower limit, there is no limit. So an integral whose limits of integration are not defined, we call it an indefinite integral. A good example is part A. So this is an indefinite. This is an indefinite integral. That is an integral whose limits of integration are not defined. Then for the case of indefinite integrals, the constant of integration, is retained. It is retained during the process of integration. So to understand that, we check example 5, which is a past cases equation tested in 2015, paper 2, number 13. So part A reads that evaluate the integral of x squared, then of course plus 2x, then of course minus 15, then dx. So dx simply means that we are integrating with respect to x. Therefore, if we integrate the first term, which is x squared, we're gonna have x squared. Then of course we add 1 to the power. Then we divide by the new power, which is 2 plus 1. Then we integrate the second term. It means this is power 1. Therefore, this will be 2x to the power of 1. So that means we add 1 to the power. Then we divide by the new power. Then minus 15. Of course, this one means it was x power 0 because we are integrating with respect to x. So this is x power 0. So to integrate, we add 1 to the power, then divide by the new power, which is 0 plus 1. Then of course we add an arbitrary constant of integration. So this will be x to the power of 3, that is 2 plus 1, divided by 2 plus 1 will get 3, then plus 2, x to the power of 1 plus 1 will give us 2, divided by 1 plus 1 will get 2, then minus 15, x to the power of 0 plus 1 will get 1, divided by 0 plus 1 will get 1, plus the constant of integration. So clearly the 2 and 2 will cancel out. So that means we remain with x to the power of 3, then of course divided by 3, then plus x squared, then of course minus 15x, then plus c. Therefore, this is what we are calling our indefinite integral. You can see that the value of c is not defined. Then we check part B of the question, whereby we are now dealing with the same integral, but now the limits of integration have been defined. So in part B, we are told to integrate. We are finding the integral from 2, which is the lower limit, up to 4, which is the upper limit of the same equation, which is x squared. then of course plus 2x minus 15 dx. Of course, if you integrate, we usually take it into what we call the box or rectangular brackets. Of course, the integral of x squared was giving us x to the power of 3, then divided by 3, then plus the integral of 2x was giving us x to the power of 2, as you can see in this particular working. Then of course minus, this one was giving us 15x. So this is 15x, but we said that under definite integrals, that is whenever the limits of integration are given, we don't need the constant of integration. So I'm not going to add the c, because even if you add it, it's going to disappear or cancel out during the process of substituting the limits. So we start by substituting the upper limit, which is 4. So we're going to have the following. So this will be 4 to the power of 3. So because where we have x, we substitute with the 4, then divided by 3, then plus, we substitute where there is x, we substitute with 4. This is x squared. Then of course minus 15 into 4. Then after that, what we are going to do is we subtract, then we substitute the second limit, which is now 2. So this will be 2 to the power of 3. Then of course divided by 3. Then plus, the limit is now 2 squared. Then of course minus 15 into 2. Then of course we close the bracket. So this will give us the following. So 4 cubed, of course, that is 64. Then over 3. Then plus 4 squared, that is 16 minus 15 multiplied by 4. This will give us 60. So we'll have 60, then minus into bracket 2 cubed, that is 8 over 3. Then plus 2 squared, that is 4 minus 15 by 2. Of course, that will be 30. So on subtraction, this is what we are going to get. You take 64 over 3 plus 16 minus 60. Your calculator will give you negative 68. Negative 68 over 3 as the first bracket. Then of course minus. In the second bracket, we are going to take 8 over 3 plus 4 minus 30. Your calculator is going to give you negative 70 over 3. So this will give us negative 68 over 3. Then of course minus 70 over 3. Minus of course will give us plus. Therefore negative 68 over 3. Then plus 70 over 3. Your calculator is going to give you so the LCM of course will be 3. So by 3, of course this will be negative 68, then plus 3 into 3, 1 times 70. This will give us 70. So negative 68 over, that is negative 68 plus 70, will get positive 2 over 3. Therefore, the final answer will be 2 over 3 square units. 2 over 3 square units. So square units, because whenever you integrate, then with the limits, what you are finding is the area under a given curve. That is why it is in square units. Then we check example 6, which is also a past case question tested in 1991, paper 1, question number 14. It reads that evaluate the integral from negative 1 up to 3 of 2x plus 3 dx, which is a question worth 3 marks. So of course, we're going to introduce box brackets or rectangular brackets. So we integrate the first part. Of course, this will be 2x to the power. It means that this was power 1. So we have power 1. So we add 1 to the power, then divide by the new power, of course, which is 1 plus 1, which will yield 2. Then plus, it means this was x to the power of 0, because we are integrating with respect to x. So this is 3x power 0. We add 1 to the power, divide by the new power. Then of course, we close the bracket. The limit is from negative 1 up to 3. Remember, for definite integrals, we don't add the constant because it will disappear anyway during the substitution process. So we are remaining with the following. So this is 2x to the power of 2 divided by 1 plus 1 is 2. Then plus 3x to the power of 1 over 1. Then the limit of integration is from negative 1 up to 3. So that means we are having the following. of course the 2 and 2 will cancel out. So we are going to remain with x squared, then plus this will be 3x. Then the limit is from -1 up to 3. So this one means that we are going to have the following. So when we substitute, this is what we are going to have. So in the first bracket, we'll start by substituting our upper limit, of course, which is 3, so that we're going to have the following. So the first bracket will have 3 squared, because it is x squared, then plus 3 into 3, close the bracket, minus the second bracket, we're going to substitute -1. So this will be -1 squared, because it was x squared, then plus 3 into -1. So this will give us 3 squared, of course, is 9, then plus 3 by 3, this is also 9, then minus into bracket, -1 squared will give us +1, then 3 times -1, of course, we'll get -3. So 9 plus 9, of course, is 18, then minus into bracket, 1 minus 3 will get -2. So this will give us 18 minus -2. Minus multiplied by minus will give us a positive. Therefore, the answer will be 20. So, of course, the answer will be 20 square units. 20 square units. So, square units, because an integral that has limits will give us the area that is enclosed below that particular curve. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you're new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.